I welcome you back to our YouTube channel. This is our third video in this C programming video series. In our last video, we left off from a point where we're going to look at addition of variables in the C programming language. At this moment, let's dive in. Now we want to add two values. Let's say you have an integer and it's called boys, and we also have an integer called girls, and then we also have another integer called sum. We want to add boys and girls and then get a sum. Well, this is cool. We've declared three variables. However, there's also another shorthand way of declaring variables. Instead of writing 3 lines of code, we can instead put a comma here and put another comma and delete this. What this means is we have integer data type for all of the 3 variables. So we have 3 variables and each of these variables is of integer data type, and then you can go ahead to give values to these variables. Like I said earlier, a variable is an identifier. It is what represents a value. So when you say we have a variable called boys and then you say boys equals to 5, it means that this identifier is the one we are using to identify a value 5. This means that whenever we put the variable boys, it is the same as putting the value 5. Alright, we go ahead to say girls equals to 10. We have more girls than boys. We want to find the sum of boys and girls. We shall simply say boys plus girls. What this line does is to get the value 5 and put it here, and get the value 10 and put it here. So when you want to print out the sum, print a function, the sum is, and then expect an integer sum. We run this. Great, the sum is 15. So we have a 15 over here because we've added these 2 variables and the value we've given it to sum. That's why we're able to print it out here. Well, before you go any further, I want to make something clear. The way variables are named in C programming, they follow a certain criteria. All variables are case sensitive. What that means is that if you have the variable called boys and it's all lowercase, they're all small letters, if you put here capital letters boys, these 2 variables are different. They don't mean the same thing. And if you try to build and run this, the compiler will complain. You say, hey, boys is undeclared and you're calling it the same way. It goes for this. These are still different variables. Against complaining, boys is undeclared. So what that means is that you should be careful about the way you declare your variables and the way you call them. Variables in C programming are case sensitive. Another thing is we have different ways of naming variables. Now we are saying here that boys are 5. You can go ahead to say that boys and then put a 5 in front. What this means is that we can use numbers in the name of variables. You get that? And since you've changed this, we can go ahead to change everything here. We can use numbers in the names of variables, and when you run this, no problem at all, it runs successfully. Another thing is, even if we can use numbers in the names of variables, the numbers can never start. Again, the numbers can never be put at the beginning of the name of the variable. If you put here 5, let us try to change everything here, and you try to run this guy is complaining already. Invalid suffix on the integer constant. Okay, it's trying to give you a clue about what's going on here. However, what all this means is that this is a wrong way of declaring a variable. So instead, we can either put it in between or at the end. You get that? We can either put it in between or at the end. Another way of declaring variables, we can use an underscore. And an underscore can be put anywhere. It can be put at the beginning, Let's copy this everywhere. You can be put at the beginning and you build and run this, no problem at all. It can also be put in between. It can be put in between. Let's put it here and then copy this. We run it. We run this, build and run, no problem at all. And we can even put it at the end. It can end the name of the variable and there will be no problem at all. Great. So these are the three basic ways of naming variables in C programming, and with them we can have a whole lot of variables. Another thing you need to know about is the name of a variable can be as long as 64 characters. This variable is 5 characters. So when I say we can have a variable as long as 64 characters, means that we can have a variable that has more letters to make 64 characters. Enough with variables. Let's go on to another thing. How about multiplication? Can we do multiplication in C programming? Of course we can. We can do multiplication. Now let's say we have buyers here. Buyers, let's remove this line as well. We have buyers and we also have products. We have buyers and products. And we also have prices. Okay, instead of prices, let us call it cost. Now, we say buyers. We have 20 buyers like before. And we have 9 products like before. Hey, how about the cost of each product? Let's say the cost of each product is 400. This 400 can be dollars, it can be shillings, it can be kwai, depending on which currency you prefer. Now, we want to get the total cost. We shall go ahead to declare another variable called total. And to make our naming for variables meaningful, we can go ahead to write an underscore and say total cost, so that it's not ambiguous and hanging. We make it clear that it's total cost. And then say total cost equals the number of products times cost. In C programming, this is the symbol we use for multiplication. So what this total cost is going to be holding is products multiplied by cost, and we can think of what the answer will be. If you try to print this one out, total cost is we expect an integer, because of course total cost we've made it of type integer. Total cost is, we'll try running this and we are getting total cost as 3600. Indeed, this is the product of 400 times 9. It gives us 3600. This is the total cost. It can be dollars or any currency you prefer. That's how we do multiplication in C programming. How about division? We can as well do division in C programming. We've already seen that we have 9 products and we have 20 buyers. Can we divide these 9 products among these 20 buyers? Let's see how that happens. Let's see how many products each customer gets. Now each customer will get, we have how many products? We have 9 products, and we want to divide it among us 20, and we want to print that value out. Print f. Each customer gets, and then expect an integer, and then bring this and put it here. Each customer. When we run this, doesn't look nice. Let's first create a new line over here. Each customer gets 0. Why? Well, you may ask yourself why each customer is getting 0. Well, the reason is simple. 9 divided by 20 is a value which is 0 point something. And in C programming language, whenever you divide integers, we take whole numbers. We don't take decimal points. Any number after the decimal point, we leave it out. Now, what if we wanted to represent data after decimal points? What do we do? We have another data type called a float. A float is another data type, like an integer data type, and it's usually used for floating point numbers that have decimal points. Now, instead of declaring what each customer will get as an integer, we can take it away from here and instead declare it as a floating point number. Another thing is, most of the times costs won't be whole numbers, so instead of declaring cost as an integer, we can also take it out of here and we declare it as a floating point number. Cost, we are written here 20 directly, we can put buyers instead of 20. And maybe just to be sure about that, let us first take this one back here and visualize it properly. I don't talked about it that we can put numbers directly here, but actually it's the same thing. When you try to run it, of course it's not available. Let's first put it back here and we run these. We see that 0 coming up. Yeah, I think everyone's fine with that because I don't think about it and that happened. So we have a 0 over there. It's not different putting here 20 and buyers, because what buyers represents is 20 already. Well, I'm declaring fraud as each customer, so we shall remove cost from here and we shall remove each customer from here. And now let's run this again and see the output. The output is still 0. Why? Because these two are integers. These two are integers. Having this one as a double doesn't change anything. So what shall we do? In C programming, there is something called casting. We can cast an integer into another data type. We originally know that this is an integer. How can we cast it into a float? We can come here in front of it and in brackets we put float products. So the result of this is turning products into a floating point number, and then we are dividing this floating point number with an integer. The result will be a floating point number. Another thing is, whenever you want to output a float, you have to put here, instead of D, you have to put F, %F. I not talked about that earlier, but we can as well visualize it before casting this to a float. The output will still be 0, but this time around many 0.000, meaning that it's a floating point number. Now let us first cast this into a float and then run again. Great, you see that we have 0.45000, which indeed is the result of dividing 9 by 20. You get that? But now there are some excess zeros here. How can we do about these excess zeros? There is a way we can modify this output. We can say that after a point, output only 3 values. This is what it means. And when you run that, indeed it outputs only 3 values after the decimal point. We can go ahead to say, hey, I don't want that 0. Let us just have 2 of them. Great, 0.45. We've modified our output to only include 2 values after the decimal point. Alright, there is also another data type which is called double. A double is more like a float. However, it occupies more space in memory than a float. On some systems, or most of the systems, a float occupies 32 bits and a byte occupies 64 bits. That's the only difference. So what that means is that if you have a number which is quite bigger, you can use a double instead of a float. But there isn't a lot of big difference between them. We can have costs we can have costs as a double, and we come here and say that the cost is 400.5, and since this is cost, whenever you multiply a floating point number with an integer, the output will be a floating point number. So we shall also have to migrate total cost from here to a float. So let's make it a double instead of a float. Let's make it a double. Both of these are floating point numbers. However, one of them is called float, another is called a double. So total cost will equal to products times cost. And since products is a floating point number multiplied by an integer, the product will always be a floating point number. And now we shall not be outputting an integer anymore. We shall be outputting a float. And when we run this, an error, this one is being declared twice. We can delete it from here. Right, when we run this is the output, and total cost is the product of products and cost, which is this. And also you can remove those excess zeros by saying that, let's have a look. Okay, let us only retain 1 point after the 0. We can say after the point retain only 1 value. We run that, we get that beautiful looking answer. We can also create a new space after this last line so that it looks pretty more cool. Create a new line, run this. Alright, and this is our output. Alright guys, this has been about integers, floats and doubles. We talked about declaring variables, we talked about how to do addition with variables, how to do multiplication, and how to do division. We talked about integers, floats and doubles, and also the main structure of a function in the C programming language.